Okay, here's a easy inverse Laplace transform example. Why do I think this is easy?
No partial fractions.
There's no partial fractions. So if you look at this thing, you go, okay, s plus 2's on the bottom are going to basically give me some kind of
e to the
e to something, right? This guy got like some numbers, right? But then there's an s squared plus something on the bottom. So if you go look in the table,
It's a sign, right?
like, yeah, it seems like front page down a ways. When there's a number on top, it's a sign. When there's a variable on top, it's a cosine. Okay, so I'm looking at that and I'm like, that's probably a sign, give or take. So now I need to adjust constants, right? So first things first. Use linearity. Break this thing up a little bit, pull the constants that are in there out front. So I'm going to break that into 4 times the inverse Laplace transform of 1 over s plus 2. And then I'm going to do minus 5. It's the inverse Laplace transform of 1 over s squared plus 7. And then I'm going to go look at my table and be like, okay, so ways down. Ooh, I have a 1 over s minus a in my table.
So e to the minus 2.
Okay, so this dude here is an e to the minus 2t. Right?
Times 4.
Yep, times 4. And this guy, I'm leaving some space because this one's not quite right yet. So if I go look in the table, I find out that the Laplace transform of sine of omega t is omega over s squared plus omega squared. Crap.
You need a square root of 7 on top.
Yeah, so first things first, I need to match the 7 to omega squared, right? So 7 is what squared?
7.
Thank you. That is square root of 7 squared, right?
Plus or
Cool.
minus square root. Right?
No. Well, 7 is definitely square root of 7 squared, right? Yeah, be a little careful with this. If this thing's negative, you don't want to be looking at sine or cosine. You want to be looking at sinh or cosh. Right?
Yeah.
A little careful. So in this case, at least I got a square root. So I should put that square root of 7.
By the 1 and under the 5.
Yeah, I also need it on top, right? So I really want to put square root of 7 up here.
So divide by square root of 7 on the outside.
So same trick, right, from U substitution, basically. Right, slap one of those on the outside. Okay, so now I think I've adjusted. So I think I got 4 e to the minus 2t minus 5 over the square root of 7. Yeah, and then that thing's the sine of the square root of 7 times t. Cool? Check done. Good to go?
Y equals.
Well, that thing
Well,
equals,
whatever
right?
that is, yeah.
Like if this was the answer to an actual problem, I think doing this would be faster than actually doing the 7 layers, of crap that we were doing before.
Yeah.
In this case, because we have an e and a sine thing.
Yeah, so the reason really that Laplace transform is a good idea, right, is that oftentimes you get something you pretty closely recognize right away. And then you just tweak it a little bit, inverse Laplace transform, and you're done, right? And all you did was a little algebra and a little fiddling around and a little looking at a table. That said, your guys' biggest problem in executing problems, right, is just like mine. It's the algebra. So you just got to be a little careful at Magic Land, right? Because if you make an algebra mistake in here, what happens?
It's bad.
Yeah, it gets awful, right? Because what's the difference between seeing this and seeing something that I don't know how to Laplace transform? Just a little algebra error in solving, right? You see that? So slow and careful with your algebra when you're doing these. I know there's a tendency to fly through the algebra, but when you're solving IVP, really slow and careful with it so that you don't get to something that you have a hard time inverse Laplace transforming. Cool?